Okay guys, so today we're going to be solving equations with one variable, and I'm going to actually be going through this rather quickly, section 3.1 to 3.3. You did this last year in pre-algebra, but I just want to make sure everyone remembers and gets our brains thinking about solving equations in one variable again. Okay, so if I'm looking at an equation x minus 8 equals 17, the best way to approach it is to think about it as balancing the equation. Whatever you do to one side, you have to do to the other. But your goal is to isolate the variable, okay? Your goal is to isolate the variable. Okay, so in this case, I want to get the 8 to the other side, so I'm going to add 8 to both sides, okay? When I add 8 to both sides, these cancel, and I'm left with x, and x equals 25. Now, Ms. Patak, or your teacher last year, probably taught you that you can always check your answer on these by plugging them or evaluating the equation for x, substituting the x back into the equation. So 25 minus 8, does it give you 17? So you can always do that on these, and that's the nice thing about algebra, is checking our work. All right, example 2, a little bit different. Got to be careful when we've got all these negatives happening. I want to isolate x. I'm going to do that by doing the opposite operation to 13. So the opposite operation, if it's addition, would be subtraction. So I'm going to subtract 13 to both sides. You're always doing the opposite operation. All right, so these cancel. You're left with x. Negative 5 minus 13, same signs, add the numbers, keep the sign of the larger number. Okay? All right, moving on. 11 equals 32 minus y. Okay, so this one's just a little bit trickier. I want to balance, I want to isolate the y. So I'm going to bring the 32 over by doing the opposite operation so that it cancels. And we get 11 minus 32. Okay, so you got to be careful here. 11 minus 32, different signs, subtract the numbers. 32 minus 11 gives me 21. Keep the sign of the larger number, negative. But I'm left with a negative y over here. So I know that last year you learned that when you're solving, it has to be a positive value, a positive variable. So you can divide both sides or multiply both sides by negative 1, which will change the signs. So y equals 21. Okay? Hopefully we're doing so good so far. All right, getting a little bit harder. You cannot solve an equation or balance an equation until the parentheses are gone. You have to get rid of the parentheses before you can actually balance the equation. So I look at this and I say, does this plus do anything to anything in the parentheses? It doesn't, so I can actually get rid of it. Now if it were negative, that would be different. All right, so before you balance, you actually have to combine like terms on both sides, or on this side. Combining like terms is not balancing, it's combining. So we have 10 minus 2, which is going to give me 8. So 8 plus x. Now I'm ready to balance the equation. So I can take the opposite of operation to 8, which is subtraction. So I'm going to subtract 8 from both sides. And I'll get negative 6 equals x. Okay, again, parentheses, you can't balance until those parentheses are taken care of. All right, let's look at a harder example. 2 minus 3 plus y equals 6. Okay, so now this is where that parentheses matters. We are going to subtract, we're going to take the opposite of the parentheses, so we're going to distribute the negative. It's going to make everything inside the parentheses its opposite. Now we're going to combine the 2 and the negative 3, which is going to give me negative 1. Okay, now I'm isolating my y, so I'm going to add 1 to both sides. So I get negative y equals 7. I'm going to divide both sides by negative 1, and so y equals 7. All right, let me give you a second to make sure that you're caught up on that. Checking on my time here. Doing great. All right, let's move on to some harder ones. Okay, 6x equals 222. All right, so now what you have to recognize here is that 6 is actually being multiplied to the x, remember? So we have to do the opposite operation, which is division. So I'm going to divide both sides by 6. And let's see, 6 goes into 22, 3 times 18, 42, 37. So x equals 37. 222 divided by 6 is 37. All right, then what can I do? I can throw fractions into the mix. 2/3 x equals 8. Okay, so I know that, I'm hoping that last year when you learned how to do fractions, you learned that, yes, you can divide both sides by the value, okay? You can divide both sides by the value, but you can also multiply both sides by the reciprocal. Remember we talked about these reciprocals the other day, and I'm going to review this one in class tomorrow, but I can do -3/2 to both sides. So take the reciprocal of the number, okay? Because what will happen here is they'll cancel out and you'll be left with x, and then you simplify and multiply. So 2 goes into 8 4 times. 4 times -3 gives me -12. And again, I'm going to show you why this works using our rules of division, where we keep change flip. But this is just an easier technique. Multiply both sides by the reciprocal as long as the variable is already like isolated with the number. Okay. X over 3 equals -5. All right, so I want to make sure you understand that this is really 1/3, right? 1x over 3. So we multiply by the reciprocal would be 3 to both sides. So x equals -15. Okay? All right, moving on. Next page. Made it a little bit harder because I gave you a mixed number. Can't multiply it by the reciprocal if it's a mixed number. You actually have to turn it into an improper fraction. So we've got 1/4 s equals 4 times 6 is 24 plus 1, so 25 over 4. We're going to multiply both sides by the reciprocal. The reciprocal of 1/4 is 4. Okay? Simplify, then multiply. So my answer, 25. Again, multiplying both sides by the reciprocal is just a little bit easier than dividing by a fraction and then having to go through the process of keep changing and flipping. Okay, I want you to stop here for a second and I want you to give me a question. Is there anything that you have noticed that you haven't been able to do? Okay, good. If there is, write it down and ask me tomorrow. Don't forget, okay? All right, let's look at harder examples. 5n minus 9 equals 71. This is where kids start to forget what to do. Do I divide by 5 or do I add 9 first? When solving an equation in one variable, what you're actually doing, as long as all the parentheses have been taken care of, you got to do those parentheses on each side first. But you're always going to do backwards PEMDAS to solve. Backwards PEMDAS or GEMDAS. So what I mean is you have to do the addition and subtraction before the multiplication and division. So in this case I have to add 9 to both sides. I get 5n equals 80. Now I divide both sides by 5. Okay? So don't ever try to do the multiplication and division when solving before the addition and subtraction. So n equals 80 divided by 5 is 16. All right, let's try one more of those. Okay? 1/2 x plus 3 equals 9. Okay? So now first I'm going to subtract 3 to both sides. Okay? So I get 1/2 x equals 6. Yep. Multiply both sides by the reciprocal, which is 2. And so x equals 12. All right. I'm going to throw one more example in here since I have a minute. I'm going to throw in an absolute value question, okay? How about this? I'm going to make it hard. 9 minus parentheses. Absolute value of x. How about plus 7 equals 4? All right, now you got to be really careful. We never distribute a negative inside an absolute value bar, but we can distribute it to the absolute value. So be careful with the absolute value solving questions. That negative has to come in front here and be multiplied to it, and it also has to go to the 7 before you can balance the equation. Remember, you have to get rid of the parentheses before you balance. All right, so I'm going to get 9 minus the absolute value of x minus 7 equals 4. Okay? All right, so now I'm going to combine the 9 and the negative 7, and I'm going to get 2 minus absolute value of x equals 4. All right, I'm going to subtract 2 from both sides, and you get negative absolute value of x equals 2. Now here's where Coach Fred got a little tricky. I got tricky. I put the negative, it's in front now. So we have to divide it. We need a positive number. So we need a positive value here. So we're going to divide both sides by negative 1. Now I get the absolute value of x equals negative 2. Yikes. Why is that tricky? Because we've talked about this. There's no value of x, no value of x that you can plug in and take its absolute value that's going to give you a negative number. So therefore, no solution. Okay? All right, so tomorrow in class we're going to be doing a lot of practice on solving, because it is sections 3.1 to 3.3 that covers all of this. So good time to ask questions tomorrow, and we'll be looking at some harder problems, okay? Have a great night.